I welcome you to our week 5 online facilitation. I believe that you have done all the self-assessment exercise I've given you so far. Today, we are going to look at Unit 4, Atmospheric Dynamics, which is part of the Module 2. So let's introduce this. Atmospheric dynamics deals in part with the flow of fluids and gases in the atmosphere as derived from the laws of motion, such as force is equal to the product of mass and acceleration. So let me just remind you about the laws of motion. I hope you have not forgotten that the first Newton's law of motion states that a body will continue in a state of rest or moving with uniform velocity in a straight line until acted upon by impressed forces. The first law of motion is also known as the law of inertia. Okay. And then the second Newton's law of motion states that the rate of change of momentum is directly proportional to the force applied. And this takes place in the direction of the force. So it is from the second Newton's law of motion that we can get the mathematical expression of force to be equal to mass times acceleration. Okay. The third Newton's law of motion states that for every action, there is an equal and opposite reaction. Atmospheric dynamics involves the study of observations and theory dealing with all motion systems of meteorological importance. The list includes diverse phenomena as thunderstorms, tornadoes, gravity waves, tropical cyclones, extratropical cyclones, jet streams, and global scale circulations. Okay, the goal of dynamical studies is to explain the observed circulations on the basis of fundamental principles of physics. Now, the objective of this unit, at the end of this unit, you should be able to, 1, know how clouds are formed. 2, classify clouds based on atmospheric layers. 3, differentiate between thunderstorms and clouds. 4, explain the formation of thunderstorms. 5, explain atmospheric kinematics of fluid flow. 6, list and explain the various types of cloud predictions. We are expected to know this at the end of this unit. Now, what is cloud? Cloud can be said to be a large subject, and I only touch on selected topics. So clouds tend to form by air rising, expanding, and cooling. They occur due to the following. 1, surface heating and free convection. Don't forget, convection is a means of heat transfer through liquids and fluids. And the second, they occur due to uplift along topography, including mountains. I said they occur due to uplift along topography, including mountains. 3, they occur due to widespread ascent due to convergence of surface air. Then 4, they occur due to uplift along weather fronts. So there are different classifications of cloud based on atmospheric layers. One of them is cumulus, which is abbreviated as CU, or cumulonimbus, cumulonimbus, which is abbreviated as CB. Stratus, which is abbreviated as ST, and stratocumulus, which is abbreviated as SC. Also, nimbus stratus, which is abbreviated as NS. Okay. Now, the polar for the first classification is less than 2 kilometers. And then the mid-latitude for that is also less than 2 kilometers. And then the tropics is also less than 2 kilometers. That is at polar, it is less than 2 kilometers. At mid-latitude, it is less than 2 kilometers. And at tropics, it is less than 2 kilometers. Now, the second classification is altostratus, AS, altocumulus, AC. And at polar, it is between 2 to 4 kilometers. And at mid-latitude, it is between 2 to 7 kilometers. And at tropics, it is between 2 to 8 kilometers. Then the third one, cirrus, CI, or cirrostratus, CS. At polar, it is 3 to 8 kilometers. At mid-latitude, it is 5 to 13 kilometers. And at tropics, it is 6 to 18 kilometers. Now, thunderstorms. We all know thunderstorms. Sometimes during rain, the thunderstorms usually happen, or even before the rain or after the rain. Now, thunderstorms are very tall clouds that extend from near surface up to and often slightly above the top of the troposphere. They are at the bottom layer of the atmosphere. A thunderstorm has a characteristic cylindrical or slight hourglass shape with a puffy cauliflower texture. Clouds with this texture are called cumulus, and clouds that produce rain are called nimbus. So if we go out during rainy season and look at the sky just before rain comes, the cloud we see that gathers to produce rain are called nimbus. Because thunderstorms are a combination of these two, they are called cumulonimbus clouds. Cumulonimbus clouds. Okay, many thunderstorms develop an anvil-shaped top, as the top is cut off by high altitude wind. Weak thunderstorms are called thunder showers. Don't forget, weak thunderstorms are called thunder showers. Some thunder showers are so weak that they produce vega. Vega is rain falling from the cloud that evaporates even before reaching the ground. Okay. Formation of thunderstorms. How are thunderstorms formed? One, thunderstorms form when the air close to the ground is warm and humid. Okay. When this warm air lifts, it becomes cooler and the water vapor in the air condenses, forming a cloud. Okay. So don't forget. Then if the cloud is warmer than the surrounding unsaturated cloudless air, then the cloud will continue to rise. This causes the cloud to accelerate upward in the form of turbulent bubbles, giving the cloud its characteristic cumulus shape. A variety of conditions can cause the lifting needed to initiate these clouds, including the heating of the cloud, wind blowing up and over a mountain, sea breezes, cold fronts, and tropical low pressure systems. There are others which you can check on literatures. The greater the temperature difference between the relatively warm cloud and its surrounding air, the more vigorous the thunderstorm will be. If the wind speed and wind direction change significantly with height, the thunderstorm can rotate. This rotating thunderstorm provides a circulation that, when concentrated in a small area, results in a tornado. Okay. Now, atmospheric kinematics of fluid flow. Kinematics, from Greek to move, is the branch of classical mechanics that describes the motion of bodies, objects, and systems, groups of objects, without consideration of the forces that cause the motion. In describing moving fluids, the following definitions apply to lines of flow. Streamlines are a family of curves that are instantaneously tangent to the velocity vector of the flow. Now we are talking of atmospheric flow, kinematics of fluid flow. So let's not be confused. Straight lines are the locus of points of all the fluid particles that have passed continuously through a particular spatial point in the past. Dye steadily injected into the fluid at a fixed point extends along a straight line. Then the next one is the path lines. Path lines are the trajectories that individual fluid particles follow. This can be thought of as a recording of the path a fluid element in the flow takes over a certain period. The direction the path takes will be determined by the streamlines of the fluid at each moment in time. Atmospheric dynamics. 1. Dynamics involves the study of the time evolution of physical processes under the influence of the laws affecting motion, including force equals to product of mass and acceleration. Okay. Atmospheric dynamics deals in part with the flow of fluids and gases in the atmosphere as derived from the laws of motion. Atmospheric dynamics involves the study of observations and theory dealing with all motion systems of meteorological importance. The list includes diverse phenomena as thunderstorms, tornadoes, gravity waves, tropical cyclones, extratropical cyclones, jet streams, and global scale circulations. The goal of dynamical studies is to explain the observed circulations on the basis of fundamental principles of physics. Weather prediction. Okay, weather prediction. How can you predict the weather? You know, we did part of it above. And I think the last 2 weeks we touched a bit of it. But now let's look at what we have today. Weather prediction from local signs. This has been the subject of human experience and popular wisdom for millennia, at least back to Theophrastus. A valid example is a halo around the sun or moon means that rain is on its way. Another familiar example is red sky in the morning, sailor's warning. Red sky at night, sailor's delight. So when sailors see red sky in the morning, there is a warning to them. But red sky at night, is something to be happy among sailors. This saying only applies to mid-latitude locations. Winds are easterly in the tropics, And in the high latitudes, the sun rises and sets at a large deviation from the east-west trajectory. Now, storm systems in the middle latitude generally move west to east. A red sky in the morning implies the rising sun in the east is shining on clouds to the west, and conditions are clear to the east. Clouds moving from the west indicate an approaching storm system. I hope we are understanding this, how to predict these storms and the weather. A red sky at night implies the sun is setting in the west, is shining on clouds to the east, and conditions are clear to the west because the sun can be seen setting. If you can see the sunset, then the sky will be redder. Clouds to the east indicate an exciting storm system in the middle latitude. Upper level clouds are noted for giving the sky a reddish hue during dawn or dusk, reddish color during dawn or dusk. Types of weather prediction. There are various types of weather prediction. One of them is cloud watching. When you keep looking at the cloud to observe, one can infer warm advection aloft, increasing air stability, and cold advection aloft, increasing air instability, towering cumulus and showers by watching the clouds. Winds that veer means change direction clockwise with height, indicate warm advection, whereas winds that back change direction counterclockwise with height indicate cold advection. That is horizontal transfer of heat by air. Okay. Now the next type of weather prediction is surface charts. Surface charts. These are useful for short-range weather prediction, especially if we have maps from several days previously as well. The following rules of thumb are used. 1, mid-latitude cyclonic storms and fronts tend to move in the same direction and at approximately the same speed as they did during the previous 6 hours. Now, 2, low pressure areas tend to move in a direction that is parallel to the isobars in the warm air ahead of the cold front. Okay. Then the third one is lows tend to move towards the region of greatest pressure drop, while highs tend to move toward the region of greatest rise. The next types of weather prediction is cloud watching, as I said. Okay, numerical prediction. Numerical prediction, modern weather prediction begins with numerical weather prediction. Numerical weather prediction uses current weather conditions as input into mathematical models of the atmosphere to predict the weather. Okay, so I'm giving you another self-assessment exercise, which says you should extensively discuss the classification of clouds based on atmospheric layers. I expect you to do this. Okay, then in conclusion, in this unit, we have learned that clouds occur due to surface heating, free convection, uplift along topography, including mountains, widespread ascent due to convergence of surface air, and uplift along weather fronts. Okay. Then in summary, in this unit, we learned that clouds are formed by air rising, expanding, and cooling. Then clouds occur due to one, surface heating and free convection. Two, uplift along topography, including mountains. Are we together? Then widespread ascent due to convergence of surface air, as we said, and uplift along weather fronts. Then we also learned that thunderstorms are very tall clouds that extend from near the ground up to and often slightly above the top of the troposphere. We should not forget that the troposphere is the first layer of the atmosphere, the bottom layer of the atmosphere. Okay. Now, we also learned that the thunderstorm has a characteristic cylindrical or slight hourglass, shower, puffy, cauliflower texture. And clouds with this texture are called cumulus. And clouds that produce rain are called nimbus. Let's not forget that. Weak thunderstorms are called thunder showers. And then thunderstorms form when the air close to the ground is warm and humid. Streamlines, decline, and path lines, all we have discussed them. So atmospheric dynamics involves the study of observations and theory dealing with all motion systems of meteorological importance. So Unit 5 under Module 2, that is the space environment. Space is a place. Some people think of space as a nebulous region far above their heads, extending out to infinity. But for us, in atmospheric or space physics, space is a place where things happen. Spacecraft orbit Earth, planets orbit the sun, and the sun revolves around the center of our galaxy. In this unit, we will look at this place we call space, exploring where it begins and how far it extends. We will see that space is actually very close. Then, starting with our local neighborhood, we will take a mind-expanding tour beyond the galaxy to see what is in space. Next, we'll see what space is like. Before our astronauts take any trip, they usually check the weather to see how they must prepare themselves and their machines to handle this hostile environment. Although in the night sky, the moon looks really far away. Earth's atmosphere is relatively shallow, so space is close. Our objective of this unit, you are expected to be able to explain where space begins and describe our place in the universe. Two, you should be able to list the major hazards of the space environment and describe their effects on spacecraft. And then third, you should be able to list and describe the major hazards of the space environment that pose a problem for humans living and working in space. Now, where is space? Where is space? That is the question. If space is a place, where is it? Safe within the cocoon of Earth's atmosphere, we can stare into the night sky at thousands of stars spanning millions of light years. We know space begins somewhere above our heads, but how far? If we push the envelope of a powerful jet fighter plane, we can barely make it to a height where the sky takes on a purplish color and stars become visible in daylight. But even then, we are not quite in space. Only by climbing aboard a rocket can we escape Earth's atmosphere into the realm we normally think of as space. Exactly. On the surface of the Earth, we should not forget that the force of gravity keeps us on the surface of the Earth. If we try to jump, we come back. The Earth is like a big magnet. Now, to escape from the atmosphere, from the Earth's atmosphere, into outer space, into space, we must acquire a velocity called the escape velocity, which is v equals to square root of 2g r. G, where g is acceleration due to gravity, and r is the radius of the earth. So if we do that, we have the velocity as equals to approximately 11 kilometers per second. That is the speed we must acquire to leave the surface of the earth. And that is the speed of rockets. And that is what they use to escape into the outer space. That is the speed. Now the solar system. Let's not forget that the solar system consists of what? The sun, the stars, and the 9 planets. Mercury, Venus, Earth, Mars, Saturn, Jupiter, Uranus, Neptune, and Pluto. All these 9 planets, they are part of the solar system. Now, at the center of the solar system is the star closest to the Earth, the sun. The sun has the biggest effect on the space environment. As stars go, our sun is quite ordinary. It is just one small yellow star out of billions in the galaxy, fueled by nuclear fusion. It combines or fuses 600 million tons of hydrogen each second. Can you beat that? The sun fuses 600 million tons of hydrogen each second. Now, we are most interested in 2 byproducts of the fusion process. One is the electromagnetic radiation taking place. The 2 is the charged particles. Now, the energy released by nuclear fusion is governed by the Einstein's formula, which is what E equals to mc squared, where E is the energy, m in mass in kilogram, and c is the speed of light. This energy, of course, makes life on Earth possible. Okay? So, I believe we have learned a lot today. And I would advise you to check the course material, PHY 205, and you see the tutor mark assignment. Expect you to do that. And by next week, we'll continue where we have stopped today. So I wish you all the best, and I hope you will take your course more serious. And I wish you all the best. Thank you, and see you